Hello guys, you're welcome to my channel. Today we are going to put solution to some exam from Uniben. As we are starting from question number 1. But before we start, we need to give thanks to young prof as he suggests all this problem for us to solve in order to make the student excel academically. So if you are watching this video, I'd like you to take your time to watch as I will be breaking every question down to the level of your understanding such that you will be able to apply this particular knowledge into subsequent questions. Now, the first question, as you can see on the screen, we are asked to find the fourth root of the complex number, the square root of 3 minus I divided by 1 plus I. And we are asked to leave our answer in form of arrow cos of theta plus I sine of theta, such that our r is in surd form and theta, which is the principal argument, is in terms of pi radian. Now class, I would like you to understand something. When you are asked to look for the nth root of a complex number, let's take for instance that the complex number is z. If z is the complex number and you are asked to look for the nth root of this z, so the nth root of this z is going to be the nth root of r into bracket cos theta plus I sine of theta. This will be the nth root of any complex number, where theta, which is the principal argument, is alpha plus 2 pi k divided by n. That is, if they want you to leave the principal argument in terms of radian, so this will be in radian. Now, supposing that the examiner wants you to leave the answer in degree, so theta, instead of being this, theta will become alpha plus 360k divided by n. So this will be the value in degree. Now, supposing you are now asking me, or you ask that what will now be the value of k, or how are we going to determine k? The value of k range from 0, 1, 2, 3 down to n minus 1. That is, if you are given that find the fourth root, your k is going to range from 0, 1 to 3. If you are asked to look for the fifth root, your k will be 0, 1, 2, 3, then 4. If you are looking for the third root, then it's going to be what? 0, 1, 2. So that's that for k. Now, we are given that the complex number z is the square root of 3 minus I divided by 1 plus I. Now, we need to determine the value of all this unknown here. Remember, we are looking for fourth root. Automatically, our n is going to be 4. We have our n to be 4. And we have our z, which is the complex number, root 3 minus I divided by 1 plus I. Now, we are yet to know the value of r and the value of theta. Now, the value of r is equal to the square root of x squared plus y squared. That is, if you are given a complex number, z equal x plus iy. If this is a complex number you are given, then r is going to be x squared plus y squared. Now, what about the value of alpha? The value of alpha is, the term of alpha is going to be b all over what? It's going to be y over x. So, alpha is arctan of y over x. So, whatever value we have here is the value of alpha. Now, let's first of all determine the value of r. Then when we get the value of r, we come for the value of what? Alpha. Okay? So, if I have my complex number z to be the square root of 3 minus I divided by 1 plus I. Remember, when you are talking about irrational numbers are those numbers with non-terminated, non-repeated decimal. So because they have non-terminated, non-repeated decimal, you cannot express them as a fraction. So when you find an irrational number at the denominator, you need to take it away from that denominator by rationalizing. Now this is complex number high here. High is an irrational number because it's the square root of -1. So there is need for us now to rationalize this function. So if we are to rationalize, we are to multiply both numerator and denominator by the conjugate of the number at the denominator. So the conjugate of 1 plus I is going to be 1 minus I. So we are multiplying both numerator and denominator by this. So when we multiply both numerator and denominator by this, then we have z to become the square root of 3 plus 1 over 2 minus the square root of 3 plus 1 over 2i. So after to rationalize this function, we arrive at this. So this one is going to be our x and this will be our y. If that should be the case, we can then find the value of r. So r now is equal to the square root of root 3 plus 1 over 2 all square plus negative root 3 plus 1 over 2 all square. So I believe we are following. So by the time I take the value of this sum, when I take the value of this, I'm going to have that my r is equal to the square root of 2 plus root 3. So if my r is equal to the square root of 2 plus root 3, then I can find my argument, my alpha now rather, so that I can find my argument, then we slot it into the formula. So we have that alpha is equals to arctan of, this is going to be our y now, and this is our x. So we are going to have negative root 3 plus 1 divided by 2, then divided by root 3 plus 1 over 2. So alpha will then equal arctan of -1. So if alpha is equals to arctan of -1, the question now is, alpha is to what quadrant? I know major problem that students face when it comes to this place is to determine the quadrant that this particular angle falls to. Don't worry, all problem becomes easier. If I have a complex number x plus iy, if I want to know the quadrant that my alpha falls to, if this one is positive and this y is also positive, then alpha is said to be in the first quadrant. Now, for you to see what I'm saying clearly, should in case you don't need to cram mathematics, just understand it. If I have this as my y-axis, here will be positive, here will be negative x, and positive x. So if this one is positive and this one is also positive, when you plot the graph, it's going to fall down to this place. You can see that's why it's first quadrant. But if x is negative and y is positive, when you plot the graph, it's facing this place. So if x is negative and y is positive, your alpha will be in second quadrant. Then, if I now have that x is negative and y is also negative, that is, here is negative, it will fall to what? Third quadrant. And when you now look at x, if x is what? Positive, then y is what? Negative. Your alpha will fall to the fourth quadrant. Your alpha will fall to the fourth quadrant. So automatically, if you look at this particular function, you see that our y is negative. Now that y is negative and our x is positive, it means that the value of alpha is going to be in fourth quadrant. Now, what value of alpha, as in what value of tan, will give us -1 in the fourth quadrant? So we have that alpha is 315 degree. So if alpha is now what? 315 degree, because it falls into third quadrant. Remember, in fourth quadrant, the value of theta is 360 minus theta. Your theta must not what? Be negative. It has to be positive. So 360 minus what? Theta, that is, you are going to have it to be what? 315. Because theta has to be 45. Tan of 45 degrees is what will give you what? 1. So it has to be positive. 360 minus 45 will give you what? 315 degree. And that's the value of alpha. Now, there is need for us to convert this to radian, because this is currently in degree. And how can we convert this to radian? Remember that if I have pi in radian, is equivalent to 180 in degree. Now, 1 degree is equivalent to pi over 180 in radian. I'm just trying to recall this. So if this is what I have, I want to convert 315 out to radian. This will become 315 degree to equal 315 pi over 180. Okay, let me quickly punch my calculator and see what the value will look like. That is, what will be the value for 315 divided by what? 18. So 315 divided by 180 rather. So I'll be having 7 over 4. Hence, 315 degree is equivalent to 7 pi all over 4. So I have 7 pi over 4 now to be my what? Alpha. Now I've determined the value of what? R, and I've determined the value of what? Alpha. Then we can go now. Are we following? If yes, and you understand this, kindly drop what? Your comments at the comment section below. Okay? So we can move on now. Since we've known the value of R to be the square root of 2 plus root 3, we have known the value of alpha to be 7 pi all over 4. Now, the nth root, the fourth root of the complex number z. Remember, our complex number z is the square root of 3 minus I divided by 1 plus I. Isn't it? Yes. Okay? The fourth root of this complex number z now will now be the fourth root of root 3 minus I divided by 1 plus I, and this will become the fourth root of the square root of 2 plus root 3 into brackets cos theta plus I sine theta. Wow. What is the value of theta? You don't know. Okay, you know, because you know that theta is equal to alpha plus 2 pi k all over n. Now, if you look at this now, n is equals to 4. So, when k is equals to 1, theta is going to be alpha all over what? N. Is that not? And our alpha is what? 7 pi over 4. So, this will become 7 pi over 4 divided by what? 4. And this will in turn become 7 pi all over what? 16. Hence, the first root, which is, we are looking for the fourth root. So, our first value will be, so this will become, cos, our theta is going to be what? 7 pi over what? 16 plus I sine 7 pi over 16. So this is the first root. So the second root will now be, the first root should be when k is 0. Sorry for that. So when k is 0, this is our first root now. Now let us find our second root when k becomes what? 1. So I can clear this now. This is the first root. Note it down. So when k is equal to 1, that's our second root now. We are still going to have that the square root, that is the fourth root of the square root of 3 minus I divided by 1 plus I to equal the fourth root of the square root of 2 plus root 3 into bracket. Now, what's going to be the value of theta? The value of theta is going to be 7 pi over 4 plus 2 pi divided by what? 4. So this should give us, if I multiply this by 4, I'm going to have 8. Okay? If this one gives me 8, I'm going to have 7 plus 8. That's going to give me 15. So I will have 15 pi, my theta, when k is equals to 2, is going to be 15 pi over 16. Okay? If this should be the case, then I can then look for cos. So I'll then have cos 15 pi over 16 plus I sine 15 pi over 16. So this will be our second root. So the third root will be when k is 2. So when k is 2, our theta is going to be, this will become 4. 4 times 4 is 16. 16 plus 7. So what would that give us? That should give us 23, if I'm not mistaken. Abi? Okay, just check. Okay, alpha 7 pi over 4 plus 2 pi times 2, that will be 4 pi divided by 4. So 4 times 4, that's 16. 16 plus 7, that's 23. So I will have 23 pi over 16. So the third root will now be the fourth root of this minus I divided by 1 plus I equal the fourth root of the square root of 2 plus root 3 into cos of 23 pi over 16 plus I sine 23 pi over 16. So this gives us the third root. So we should now then look for the fourth one, that is when k is equal to what? 3. So when k is equals to 3, the value of theta will become, by the time you have 3 times 2, that will become 6. 6 times 4, that's 24. 24 plus 7, that should give us 31. So theta will be 31 pi over 16. Hence, the fourth root of, so this is equal to the fourth root of the square root of 2 plus root 3 into bracket cos 31 pi over 16 plus I sine 31 pi over 16. So these are the fourth roots of the complex number root 3 minus I divided by 1 plus I. So that is 1a. Can we just move down to 1b? Okay, I'll stop this video here so that I'm going to upload the B aspect. Kindly subscribe and click on the notification button so that you can follow the remaining solution. Thank you.